All right, guys, welcome back. I don't know why, but I've been going crazy this week. Seems like too many things are happening. It's too busy. I can't keep track of everything, but hopefully you guys are doing better than me. My brain's kind of swirling around. I was just thinking I gotta make sure I get up and walk more today because I keep getting stuck with my butt in this chair, sitting in front of this square, looking at it all day. I don't know about you, but this is not natural for me to sit in a chair and stare at a square all day. It just drives me crazy. So hopefully you guys are getting more used to this. I am just excited that we will be back in class soon, and I'm looking forward to it. Uh, Especially for you guys, your first project is a really cool one. It's the one where you get to do all the wiring for the house. So it teaches you how to do all the electrical that goes behind the walls of your house. It's really fun projects, and I can't wait to get in there and start that one. Oh, let me let him in. Okay. Okay. All right. So yeah, we got that first project coming up. I cannot wait for that one. I was starting to collect all the materials today for it. So that one looks good. We will be starting the electrical stuff today. And just to remind you, that is very tough, and it's the same. I used to teach college and high school, and it's the same material. So it is kind of tough. I do apologize for that, but electricity is a little complicated, and you can only simplify it so much. So it's a tough class, and we're going to be launching into it today. It's actually it's kind of a depressing day in a sense, because we're going to be doing electrical safety. We start with that, and I want to show you some of the effects of what electricity can do to a person, because it's one of the highest paid fields. It's one of the coolest fields because it's really it takes a lot of brain power to figure it out a lot of times. So it's really fun job too, and it's very high paying, but it's also very dangerous. Okay, and you do not want the common idiot messing around with electricity. Engineers go to very, very, very long lengths to make sure electricity stays away from people. If you notice, it's always tucked behind walls. It's hidden in steel conduit. In large part, we try to keep electricity away from people as as much as possible. And the reason is because it's dangerous. Now, you guys all inherently know that because you're shop students, but the average person just doesn't realize how dangerous electricity can be because people are so smart at keeping them away from it. So we're going to be launching into that today. But like I said, the safety side of it can be a little depressing. So we're going to watch some stuff today, and we're even going to watch what electricity does when it kills somebody, okay? Because that's always a danger that we have to face when we deal with electricity, is that it could be so dangerous that it actually kills us, okay? And that's one of the reasons people get paid a lot. And the more dangerous the electrical grid that you're working with, the more training and expertise you're going to have, and also usually the higher you're going to get paid too. The slower you work, the higher you get paid, the more tools you have. So we'll talk about that. But there's a ton of careers in the electrical industry, tons and tons and tons of different ones. You have the people that climb up the poles and work on them. You have people that dig trenches underground to work on electricity. We have electricity that goes at the floor of the ocean. We have electricity that goes through tunnels, like through mountains and everything. And we have electricity that goes through the air on telephone poles and wires. So lots of different places where there's electricity. Even weird places too. Like we have electricity on the space shuttle and the International Space Station and things like that. So electricity really can take you everywhere, and it just depends on your education and training level. Look at this guy, electrons moving around back and forth. You know, this just brings a smile to my face, seeing all this nerd talk like that. Love it. Okay, very nice. Someone's been doing some research. I like it. Yes, indeed. Yeah. And as electricians, we don't need to know all the science of it, but I do like you to know the basics of it. Oh, we got some new people. Let me let them in real quick. Okay. Okay, so that being said, let me share my screen with you and we will start some of this electrical stuff. Now we will be taking notes on some of this, but the stuff we're doing today, I'm not going to make you take notes. I just want you to watch it and have the gravity of what we're watching sink into you, okay? Let's see here, there it is, I believe, okay. Okay, so I will share the screen. So again, we will take notes on this, but today I just want you to kind of sit back, relax, and just let the cool factor of electricity, because we will be doing some cool stuff with it, and then also the gravity of what can happen if it goes wrong. Okay, and we're always going to have to protect ourselves so that we can't be electrically shocked. Okay. All right. Let's go through here. Okay, I am sharing my screen. So if you look, electricity is all around us. Very few minutes of the day go by when you are not utilizing electricity in some way, whether it is checking your watch, driving your car, sitting in an air-conditioned room, or using your cell phone. It is easy to take electricity for granted since we have it all around us, use it constantly. When working with electricity, safety is of the utmost importance. Sorry, we have electricity all around us and use it constantly. When working with electricity, though, safety is of the utmost importance. Electrical injuries may include electrical shock, electrocution, which, by the way, that means you've had so much electricity in you that you die. Okay, so you could get shocked, you could have electrocution, you could have burns, or you could fall down off of things. So you don't always think about that, but oftentimes you'll be working on a ladder or up on an elevated platform when you're working with electricity. And since it can control your muscles, which we'll talk about later, it can cause all kinds of accidents, including falls. Electrocution counts for 12% of all workplace deaths among young people. Okay, so 12% of all workplace deaths among young people. Now, that does not mean that these are electricians. Okay, by any means, it by no means does it mean they're electricians. It just means that of the young people that die at work, 12% of them are from electricity. And that could be like you're stepping in a puddle, grabbing a plug. That could be one of the plugs got chewed through by a rat and you grab it on accident and it shocks you. Could be any of those things. But just to show you, 12% of all the deaths of young people at work are from electricity. So definitely something to take seriously.
I have a question.
Yeah, go ahead. Yeah, I have a hard time seeing questions when I'm doing the shared screen, so just verbalize it if you need it.
So my PS3, I have.
You got to speak up. I could barely hear you.
Is it better now? Is it better now?
I can't hear him. Was anyone able to hear that?
It's plus.
Can you hear me now? Can you hear me now?
Yes,
Yeah.
now we can hear you.
Okay, I thought like screaming to my mic.
That's okay.
It's kind of bad. But so I have a PS3 and I have a charger because I bought it off someone, and it's all chewed up. The power cord for the controller is like chewed marks all over it. And if I touched it when it's plugged in, power's going through it, but I'll electrocute myself.
Cut out right at the juicy part.
So the end of my
You touched it and
charger,
what happened?
Yeah, if I touched it, what would happen?
You touched it and something happened, but I couldn't hear you.
If he touched it, what would happen if he touched it?
Okay, so that's a good question. What would happen? So you will learn about this through this course, but there's two kinds of electricity. There's alternating current and direct current. And computers use lower voltage. So typically a computer is going to use 12 volts, 9 volts, 3 volts, or 1.5 volts. I think it's 3.3 actually. So they use a number of smaller voltages depending on what the application is. So an Xbox is going to be both alternating current because that's what comes out of your wall, and then it's going to need its direct current. We'll talk about this later on. But the voltage is going to be stepped down quite a bit. So if you touched it on the side with the plug that goes into the wall, that thicker plug, if you touched it there, you're going to be shocked by 120 volts of electricity. If you touch it on the other side of that little square box that like the plug goes into, there's a little square box and then a smaller wire comes out. So if you're on the big side of the wire, you're going to get shocked with 120 volts. If you're on the other side of the wire, you're probably going to get shocked with 12 volts. So one side would give you quite a bit of a shock. The other side would give you a very small shock. So it just kind of depends on where you touched it. Things like cell phones and all that, you know how there's that big plastic box at the plug, you plug it in and then it goes to that tiny little wire. So that box changes it from that 120 volts to whatever your phone's using. It's usually going to be around 12 volts or so, 10, 12 volts, sometimes 9 also.
So if I touch the end of it, I'll get shocked with like 12 volts.
Yes, as long as it's the small sized wire, yeah.
By small, do you mean like the stuff where it like if I go outside and like touch the like the spring on my trampoline, sometimes I'll get shocked a little bit. Is like that much or is it less than that?
So that's a static shock, which is kind of those are cool things too. Actually, let me show you. I got a little wall wart here. Okay, so these are called wall warts, right? And they go from the 120 volt electricity, and then it gets changed in this little wall wart, and then it comes out as the 12 volts. So you'll learn more about this as we get into it. But if I touch this side of it here, this side that you're seeing, well, that's low voltage. It's not going to do a whole lot to me. If I touch this side here, like say it was out of the wall a little bit and I touched my fingers across it, that would shock me a lot because that's going to be 120 volts. So in general, it's kind of an idiot's guide to safety. A small wire is going to carry only a small amount of electricity, and a big wire is going to carry a lot of electricity.
Oh wait, I forgot. How much is the amount to killing a normal adult human?
We're going to talk about that in a second. It's extraordinarily small for some people, okay? So that's one thing we're gonna cover today, and I wanna make sure I get to it because I know these classes are so super short. Let's see, we're out of here at 1:37. Yeah, these are super short classes, so. Okay, let's get back to this. Great strides have been undertaken by designers, engineers, and technicians to make our electrical use safe. But if you start messing around with electricity, you'd better know what you're doing, okay? And that's where we come in. That's why people pay us big dollars, because we can come in there and start fixing electrical problems that they can't. It's too dangerous for them to do because they don't know how to do it. But that's where we come in, and that's why we make a lot of money. Especially with electricity, you're gonna have to have professionals working on it. You do not want people that don't know what they're doing touching electricity. It's gonna be dangerous for everyone involved. Okay, so let's watch this first video here. Hopefully this won't lag too much. I know sometimes it's easier to have you guys watch on your computers, but I thought I'd try it today and just see. So I'm gonna play it and you guys can let me know if it lags too much, and if it does, I'll have to have you watch it on your own. All right, here we go.
This is the static electricity machine. It's called a Van de Graaff generator, and you and I have never done this before, and this is a brand new one. I've never even tried this one out on 9 News before, so this is great. This is how we teach kids about electrons, and really an electron elevator and how it sends the electrons over the top here. So here's what happens. There's a crank that's here. Right. The crank's going to turn the motor on the bottom, and when I turn it like this, you're going to actually start to feel some of the, oh, do you feel that? There's a little electricity that's in the air. Is that weird? All right, so here's what I'm going to do. You hang on to the ball, okay? And I'm going to hold on to this little grounding thing over here. And then he's going to dim the lights a little bit, and I'm going to twist it. And watch what happens here. You're going to get a nice little, get a little closer. Oh, there you go. Isn't that a great one?
That's really cool.
You get a little farther away. You get a, so for every inch of spark, it's about 50,000 volts. So
okay, I just want you guys to note that there. So we're seeing electricity jump through the air right there, right? We're seeing it jump from the ball to that stick there, and it might be going the opposite way. We'll talk about that later. But it's jumping between those two objects. Now, In order for electricity to jump through the air, it actually takes a lot of volts to do it. It's not easy for electricity to go through the air. So what he just said is it takes about 50,000 volts for electricity to jump 1 inch through the air. Okay, so that means it takes a lot of volts to do it. So our plugs in our house are only 120 volts. So they would not be able to jump an inch through the air. Okay, that would not be a very easy thing. There are ways we could facilitate it, but not an easy thing to do. In your car, we use something called a spark plug that generates a spark and ignites the air fuel mixture and creates the explosion that makes an engine work. And that's a very tiny air gap. It's about 1/8 of an inch or so, very, very small air gap. And to get the spark to jump through there, sometimes we crank the electricity up to 90,000 volts on cars. That's not uncommon. So it's usually somewhere between 30,000 and 90,000 volts just to get electricity to jump across the air. Did somebody have a question? I thought I heard somebody.
The video
How
is
much
really
volts
bad.
does a thunderbolt have?
Good question. Somebody went right there already. What about a lightning bolt? Millions and millions of volts to get a lightning bolt to drop from the clouds to the earth. Millions of volts. And surprisingly enough, people survive them sometimes too. Actually, very often they survive lightning strikes. So very interesting.
Voltage is the difference in electrons, right?
So wait, so it takes more than 1,000,000 volts to kill somebody, or is it just the kind of like current that a lightning bolt has?
I don't want to get into it too much yet because I don't want you to get weird ideas, but it's actually the amperage that kills somebody, not the voltage. So there's we rate electricity in volts, amps, and ohms. Like I said, this is why I'm saying electricity gets kind of complicated, but it's actually the amps that kill someone. Amps is going to be how much electricity goes through it. Voltage is how hard it hits. Voltage is your force, is how hard it's going to hit. It's your pressure. But your amperage is how much of the electricity is getting into you. So it's two different kind of ratings, okay? So voltage is gonna be pressure, and it takes a lot of pressure to get electricity to jump through the air. Okay, let me go back to the video here.
Oh, that was
That
a really,
was a really good one.
Now here, this is more fun. You hang on to this.
Oh,
So
okay.
hang on to this. Now you can feel it. Ready?
Oh.
So get a little closer. Ready?
Oh.
See how that?
Yeah.
Is that awesome? All right, so the lights come up because here's what we're gonna do. This cranking thing is for sissies, so we're gonna move it to the motor.
Huh?
All right?
Huh?
So here we go.
Steve,
the
now
motor.
wait a second. You said before that we were not going to do the motor.
I know, but now he's lying. So here's what we're gonna do now. So now I'm gonna hang onto this. So now when we flip on the motor here, now you really can kind of build up those electrons, and that's what we're doing. This little electron elevator
Yeah?
is sending the electrons to the top there, and it's
cow.
jumping. So we get all this negative charge. And you feel it around your body,
Yes.
don't you? Is that
What
crazy?
did you say to me earlier that this is what you feel like just before you die on pipe
Oh
speed?
no, it's this part.
Oh.
All right, so here's what I want you to do. So now you put your hand on the ball. All right,
What?
so it's okay to put this hand
Both
on the
of
ball
them?
like that. No, just one. Which hand do you use the least?
The left.
Okay, so you're there. Then you're good. So now we flip it on, and so now you're going to start to feel the electricity around your body. You start to feel it around?
Yeah, a little bit. Do you want
Yeah?
me to shake my hair out?
No.
Holy.
You see that? Yes.
Yes.
See, there's a little sparking
Okay.
there. See, that's kind of fun. Yes. So there's a little bit of sparking, but it's okay. So now here we can build up some of the electrons this way. So if
Right.
you like go this way, these are just little pipe hands. So if you start to see the repelling charges, you can kind of see what happens here. See how
Ooh.
it starts lifting up the.
That is
kind
so
of fun.
cool.
So there is this piece too. We have to tell people.
Okay, so very cool. Do you see how they're using the electricity to bump those? It's catching all the electrons in those plates, charging them, and it's making them jump out. You could do very, very cool stuff with electricity. It's one of the greatest forces on the planet, and humans have harnessed it for all kinds of magical things. So I love this stuff. This is why I always like to start my class with this video, because I think it's really cool looking. Okay, I'll go back.
People in Colorado that when the lightning hits, you count to 5, right? So when you see the flash of lightning, 1,001, 1,002, for every 5 seconds it's a mile away.
Okay.
They consider a real danger zone in Colorado between a mile and 2 miles. So believe it or not, you can count to 10, hear the thunder, and then all of a sudden that's pretty dangerous. So
Right.
you got to get out of there. Get out of
Absolutely.
there. Hey, here's our special guest, Barbie. So hang on to Barbie. All right. So
Hey,
now you put your
Barbie.
hand here.
Yes.
And now I'm going to crank this up, and you should be. There's a little of electricity in the air. Do you feel? Oh, see, see when you touch. See, is that funny? There's just a little electricity that's in.
Okay.
Okay. All right. So now, how much time we got? Okay, we've got a short amount of time, so I guess I'll launch into this one here. Now, this one is a very serious kind of topic, and so I want you guys to take it seriously as we watch this thing. Most of the time, people would never show you guys this kind of stuff, okay? This is, you can see here, it says, this video contains pictures that are not suitable for minors. You guys are all minors, okay? It's an educational video showing the dangers of electricity, okay? It's not intended to be gory, but there are gory contents in here, okay? I want you guys, we're watching this because you guys are embarking on your journey into becoming a professional. And as a professional, it's very important to understand what you're working with. And just like in the wood shop, I always try to show you what the most serious accidents can be. Same thing with electricity. I want you to see what the most dangerous, the most grisly aspects of electricity are, because only when you understand how dangerous something is, then will you respect it to the degree that it's supposed to be. And if I sugarcoat everything, you guys get overconfident and then you try things that you shouldn't do without the proper knowledge. Okay, so I'm going to show you this. Like I said, it's actually pretty grisly, but I show you it because you guys are entering the world of professionals, and it's very important that you understand this kind of stuff, because whenever you work with electricity, electrocution is always a possibility, okay?
My hands are sweating even before we start.
It's okay. You won't be working with this kind of electricity. All right. Electric shock of a human body with any source of electricity that causes a sufficient current through the skin, muscles, or hair. Typically, the expression, hold on, I gotta move this out of the way. The expression is used to denote an unwanted exposure to electricity. Hence, the effects are considered undesirable. The minimum current, this is where somebody was asking about this earlier. Okay, so listen to this. It's actually very small. The minimum current a human can feel depends on the current type, alternating or direct current, and its frequency. We'll learn about frequency later. A person can feel at least 1 milliamp of alternating current. Okay, 1 milliamp, that's 1/1000th of an amp. Okay, 1/1000th of an amp of AC current, while at least 5 milliamps for DC current. Okay, so you'd need 5/1000ths of an amp for DC current, but that's not much. That's not much at all. Okay, the current may, if it is high enough, cause tissue damage or fibrillation, which leads to cardiac arrest. Okay, and that's one of the ways people can die from electricity, is since our body and our muscles are all run with electricity, if you inject electricity into the human body, it starts to control things. Like when I try, get this here, I'll use my fingers. So if I clench my fingers, my muscles are contracting. I'm sending electricity to these muscles that will contract, or I'm sending muscles to these, electricity to these muscles that will contract. So I control that with electricity. Well, your heart is actually run the same way. It beats, boom, 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 boom. And it's being controlled with electricity. And if you send a weird surge of electricity to it, all of a sudden it gets confused and might collapse or beat too fast, and that can cause a heart attack. Okay, what we call cardiac arrest is one of the most common causes of death in the United States, is to have a cardiac arrest. This can unnaturally cause it. Okay, it will confuse your heart by sending electrical signals to it. So
How much electricity is in the normal home?
normal home is going to have 120 volts or 240 volts.
I mean, like in terms of amps and milliamp, like milliamps.
We can have up to about 50 amps. If you go to the main part of the house, you could have up to 200 amps. This is, and when we say this, what you can feel, that's a thousandths of 1 amp. Thousandths of, you take 1 amp and divide it into thousandths, you can feel one of them.
50 milliamps.
Yeah, so small, that's a small amount, okay? All right, next one up here. Okay, a sustained electric shock from alternating current at 120 volts is an especially dangerous source of ventricular, that's your heart, fibrillation, because it usually exceeds the let go threshold while not delivering enough initial energy to propel the person away from the source. Okay, so I told you we have two voltages in our house, 120 and 240. So if you look at the top here, it's saying a voltage of 120 can be particularly bad because what can happen is if I have this plug here, I go to grab the plug, what it says here is if I get shocked, it's particularly dangerous because it exceeds the let go threshold, meaning I can't let go of it while it's also not enough to propel me away. So if I got shocked with a lot of voltage, it might just throw me back out of the way so that I was safe. But in this case, what it does is it actually makes you clamp down. And I've had this. Probably a lot of you guys have been shocked before, if nothing else, at least static shocked. But I actually had one once. I was grabbing the plug for the vacuum cleaner, and I had, you know, when you vacuum cleaner, you sometimes get to the end and it pulls the plug out just slightly. So I had gone to pull the plug out of the wall. I reached down to grab the plug, and my fingers touched the two metal prongs, okay? Because it was out from the wall just a little bit. And I actually had this happen. So I was kneeling down, I go to grab the plug, my hand touches it, and I start getting electrocuted. Or electrically shocked. My arm starts tingling, and I can tell I'm being shocked, but because the electricity is controlling my arm, it's pumping into my arm, I can't let go because it's clenched my muscles down on that thing, and I can't move my arm because the electricity is flowing through my muscles. So I'm actually kneeling down, touching this plug, thinking to myself, oh my God, I'm gonna die because I can't move. Okay, I can feel it shocking my hand, and I can feel it, my whole arm actually was being shocked, but I couldn't move. I couldn't move my arm because the electricity was coursing through it, controlling my muscles, making them like clench down tight, and I couldn't do anything. And I'm thinking, like, this only took a second, but I'm thinking the whole time, like, oh my God, I'm gonna die, I gotta do something. And what I did was I moved my shoulder back, pulled my shoulder back, and I still had control of that. The electricity kind of was only controlling all the way up to like my bicep. And I was able to pull my shoulder back and pulled my hand away. But that's a perfect example of why they say that this stuff can be really dangerous because it exceeds the amount of voltage where you can let go, okay? If you touch those 12 volt things, a lot of times you'll just be able to let go. But at 120 volts, it can shock you enough to where it controls your muscles, okay?
And can we play the video because I think it's only like a few more minutes till our next class.
You know, actually, I just finished this and then we'll finish the video tomorrow, okay? However, the potential seriousness of the shock depends on paths through the body that the currents take, okay? Obviously, we have some parts of our body that are way more susceptible. Our brain and our heart are the ones where we really don't want electricity to go, okay? So death caused by an electric shock is called electrocution, and that's usually because it hits your heart. However, we will also learn that it can kill you in other ways too. Okay, I'm gonna kill this there today because we're almost out of time. These short classes go by so quick. And I've got two crazy safety things that we'll finish up tomorrow, okay? One is somebody that actually died from electrocution, and one, I don't know if they survived or not. I kind of think they did not, but we'll check and see. So we'll check those out tomorrow. Like I said, I show you this stuff not because I want to scare you, but because I want you to understand what can happen with electricity, okay? This is why we make a lot of money, because we know how to safely handle stuff that would kill the normal person, okay? All right, anyways, I'm gonna let you guys go today a few minutes early, and I will see you back tomorrow.